Well, we're going to review a little bit about simplifying radical expressions because I noticed on our math review we had a little bit of difficulty. So I think we need to have a full lesson on this. So we've tried to simplify some radicals, but we're going to add to that a little bit today. Our new vocabulary: radical expression, rationalizing the denominator, and conjugate. So we're going to learn what all those vocabulary words mean today. Our key concept. Now we've done this before where you've got a number like the square root of 36 and we're going to use our factor tree. You won't necessarily see a factor tree on this, but we're using that same process in order to find out what the answer is. So the square root of a times b is the same thing as the square root of a times the square root of b. Okay? So to simplify square roots, I want you to pause this for a moment and see what you get when you take the square root of 52. Okay, the prime factors of 52 are 2 times 13. So because there are two 2's, it's 2 squared, we're going to pull a 2 out. So our answer is 2 radical 13. 2 times the square root of 13. Here's time to check your progress. So calculate to see what you get when you're looking for the square root of 45. Okay, so it's 9 times 5, or 3 times 3 times 5, which is 3 times the square root of 5. Very good. Now we're going to multiply square roots. We've got the square root of 2 times the square root of 24. Now we can write those each under their own radical symbol. So square root of 2 times the 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 square root of 3. So if we were to use a factor tree on 24, that's what we would get. Now they went ahead and they've got 2 2's here, so that's the square root of 2 squared. Another 2 2's, so square root of 2 squared. And what it's left alone is the square root of 3. So we can pull out these 2's. So 2 times the square root of 3 is 4 times the square root of 3. Awesome. Time to check your progress. So I want you to pause the video and try to work this yourself and then go back and see if you've got the correct answer. All right, so we've got a square root of 5 times the square root of 5 times the square root of 7. So square root of 5 squared times the square root of 7 is 5 times the square root of 7. Very good. So now we're going to have a little bit more practice simplifying a square root with variables. Okay, using the same factor tree process. 45 we can break down as 3 squared times 5. And notice we've got a to the 4th, b to the 5th, c to the 6th. So we're going to break down these variables and we're going to keep those even because the square root of, you could take a square root of 4, but you can't take square root of 5. But you can take the square root of b to the 4th times square root of b. That's going to give you b to the 5th. So whenever you see an odd like that, then you can break it out. And then c to the 6th. So square root of 3 squared is 3. We're going to have radical 5 left over. Square root of a to the 4th, a squared. Square root of b to the 4th, b squared. We've got 1b left over. Now notice we've got absolute value signs around c to the 3rd. Because 3 times 2 will give us that 6. The reason we do that is because, remember I talked to you about the index. If there's no number here with the square root, we know that's a 2. So that's an even number. Underneath the radical sign, that's an even number. But our answer when we bring it out is an odd number. So whenever we've got even, our answer comes out to odd, we're going to put absolute value signs around it. That ensures that the absolute value c to the 3rd ensures a non-negative result. So this is our answer, how it's written. 3a squared b squared, absolute value of c cubed times the square root of 5b. So now time for you to check your progress. Pause the video, work the problem, and come back and see how you've done. Did you get 4 times absolute value of mn? Notice, even, odd. okay, because there's only to the first power. So that's why it's in the absolute value sign. And we've got a square root of 2c left over. Now let's talk about what we do when we're dividing them. Now, the square root of a divided by b is the same thing as the square root of a over the square root of b. So here's a standardized test example. We've got the square root of 3n over the square root of 8. So this radical expression needs to be simplified because it's not simplified as long as there's a radical in the denominator. So you can't fit, it's not in simplest form if there's a radical in the denominator. So to solve this, we've got to multiply both the numerator and the denominator by whatever the radical is. So we've got square root of 3n over the square root of 8, so we're going to multiply both by the square root of 8 over the square root of 8. So 8 times 3 is 24, so 24 square root of 24n, and the square root of 8 times the square root of 8 is 8. See how we got rid of that radical? Good job. Now we're going to do prime factorization on our numerator, see if we can simplify that any. So we can pull out one set of 2's. We're left with 2 times 3n. So square root of 6n over 4. So the correct choice was D on that one. Time to check your progress. See what you can do for this one. So what did you multiply by? Square root of 27 over square root of 27. Then start simplifying. Could you go ahead and start simplifying this first? We have a square root of 27. That's 9 times 3. 3 times 3 times 3. So 3 radical 3, right? And if we multiply by square root of 3 over square root of 3, then we get 9. And then square root of 2 times square root of 3 is the square root of 6. So you don't necessarily have to multiply by radical 27. Simplify this first and see what's left under the radical. Now we have got something a little more difficult. We need to rationalize this denominator, but there's a 4 added to this negative square root of 5. So we're going to use what's called a conjugate to simplify that. Whenever we're talking about a denominator, the conjugate is just the opposite operation. So this one's minus. So the conjugate of 4 minus radical 5 is 4 plus radical 5. Whatever you multiply the numerator by, you've got to multiply the denominator by. So we're going to multiply both of these by 4 plus radical 5. So we're going to have 2 times 4 plus radical 5, and then 4, and you just use the FOIL method. 4 times 4 is 4 squared. And because this is a plus and a minus, that means that the center one is going to eliminate. That's why we use the conjugate. So the square root of 5 times the square root of 5, square root of 5 squared. 4 squared is 16. Square root of 5 squared is 5. So we've got 16 minus 5 in the denominator. 2 times 4 is 8. 2 times radical 5 is 2 radical 5. 16 minus 5 is 11. Okay, so time to check your progress. So pause the video, work the problem, and then come back and see that your answer is correct. Very good. So your conjugate was 3 plus radical 5. Okay. So do the math. Excellent. So now time for you to work on your worksheet.